And now we're going to find the LCM by using the dividing by primes method. This is a modification of when we found the GCF. This is also another method that can find both the LCM and the GCF, and I'll tell you how to do both in one problem. So remember, we make a little list. We put the numbers next to each other. Think about a prime that goes into both. Here you can say 2. 2 goes into 112, 56 times, into 72, 36 times. We can use 2 again, because both of these numbers are even. We get 28 and 18. And guess what? We can use 2 again to get 14 and 9. 14 and 9 are relatively prime, so we stop. If you wanted the LCM, you multiply all the numbers on the outside. So the thing I like about this is it's sort of visual. This forms like the letter L for LCM. So you would say LCM is equal to 2 times 2 times 2 times 14 times 9, which is equal to 1008. And we had this problem before, so we should get the same answer. Great. If you wanted the GCF, you would only multiply the numbers off to the left. So again, this method can do both problems of an LCM and a GCF. For this, that would be 8. So it's very nice for both. Let's do the same thing for 120 and 1260. We can start off with 2. We can start with 5. Doesn't really matter. 2 gives you 60 and 630. We can do 2 again because they're both even. We get 30 and 315. 2 won't work anymore, but we can do 5. 5 gives us 6. I want to say 63, but I'm not sure. 315 divided by 5. Yay! And then 5 won't work anymore, but we can do 3. This gives us 2 and 21. And then we stop because these are relatively prime. Remember, that means their GCF is 1. Okay, pause the video. I want you to determine what the LCM and the GCF are before I tell you what the answers are. Welcome back. So the LCM, you take all the numbers off to the side and also below, and you multiply them. So it'd be, in this case, 2 times 2 times 5 times 3 times 2 times 21. And throwing that into your calculator, 2 times 2 times 5 times 3 times 2,520. That was a good year. So that's the LCM. If you also wanted to find the GCF, you only multiply the numbers off to the side. So 2 times 2 times 5 times 3 is 60. Done. Now, when you have 3 numbers like we have in part C, the GCF portion is the same. However, the LCM is a little bit trickier. So for instance, let's knock out a 2. I'm pretty sure this is 490, this is 200, and this is 945. So 2 doesn't work for all 3, but 5 works for all 3. Let's knock out a 5. And this would give us 98. This will give us 40. Oh my gosh, I don't know what that is. 189. Ugh. That's terrible. All right, so 2 doesn't work for all three. 5 doesn't work for all three. Let's see, does 3 work for all three? Nope. I don't. 7 doesn't work. 11 doesn't work for all three. 13 doesn't work. All right, so here is the deal. If you were finding a GCF, you would be done, because it's only the primes that work for all three. In this case, 10. 2 times 5 would be the GCF. But we're trying to find the LCM. And what you do is you keep dividing. If you can't do all three, then you take 2 at a time. So 98 and 40 are both even. So out of those two numbers, I can pull out a 2. In fact, let me do this in a different color. I have all the colors in the world. Might as well use a different one. So this would be 49, and this would be 20. But 2 does not go into 189, so it just drops down as 189. What are you going to do? Well, we can't do 2 anymore through any of the pairs, but 49 and 189 actually both have a 7 involved. 7 goes into 49 7 times. 7 doesn't go into 20, so what do I do with the 20? It drops down. Then 7 goes into 189 27 times. Well, 27 is 3 cubed. 20 is 2 squared times 5, and 7 is just 7. So no number goes into any of those pairs. So any pair, 7 and 20, 7 and 27, or 20 and 27 are relatively prime. So this is where we stop for the LCM. And as before now, all the numbers on the outside multiplied together give you the LCM. I'm out of room here. Let me do this. All right, so the LCM for part C would be 2 times 5 times 2 times 7 times 7 times 20 times 27 is a number. Suspense is killing me. 2 times 2, I'm just double checking. 5 times 7 times 7 times 20 times 27. I got 529,200. Woo! Awesome. So again, the prime factorization methods and the dividing by primes method can help you find both the GCF and the LCM. The Euclidean algorithm does not help you find the LCM, just the GCF. But its answer can be used if you know a little tricky formula, which is in the book, to find the LCM if you know the GCF.